coterminal angles, like we talked about in class, are kind of spirally angles. They're angles that go around and around and around multiple times in a unit circle, one way or the other, but they don't look like normal angles that you're used to, like 15 degrees, 45 degrees, 30 degrees. They look like negative 985 degrees. So we have to kind of get our heads around what that means. And the easiest way I have of describing it is with the standard coordinate plane. Let's say you've got, I don't know, we've got this guy and he's snowboarding, okay, and he does a 180. Now, 180 just means he spun around, okay, that's 180 degrees. That's no biggie. I mean, even I can do that. But if you told me someone was going to do a 540 on a snowboard, that's a much bigger deal. Okay, now you're going like this. That's 540 degrees, right? You spun around once, and then you spun around another half a time. And even though they ended up at the same place, right, they're both in the same position when they land. Obviously, the blue snowboarder is at a much different level than the red snowboarder. But we don't care about their skill level when it comes to trigonometry. We just care which direction they're facing when they're done. So when I say negative 985 degrees, that sounds like a pretty big spin. And we want to know, the question we're asking is, what other angle would land you in the same resting position when you're done spinning? Okay, so maybe, I'm just going to make a guess here. Here's an angle, and let's say negative 985 looks like this. I don't know, I really don't know where this is going to end, but it's going to look like some crazy spiral. And what I'm saying is, what's an angle on the unit circle? Okay, see, these want angles on the unit circle. What's an angle on the unit circle that ends at the same place? Well, here it is. Okay, that angle right there. It ends at the same place, even though it's nowhere near as crazy. So the way you figure out what the angle is you just start adding spirals. You add 360 degrees at a time. So, negative 985 plus 360. Okay, what do we get? Well, oh boy, that's hard. Negative 625 degrees, I hope. Okay, so then we add 360 again. And the reason I'm adding 360 again is because I know I'm not yet on the unit circle. Oh, come on. Calculator, don't fail me now. Negative 625 plus 360 is negative 265. Not good enough. We're still not on the unit circle. So I add 360 degrees again. And this time, I've got a good feeling about this. This time we get to 95 degrees. Okay, so you see my guess was totally off. That's fine. It's still the same basic idea. We have an angle 95 degrees, which is equivalent in terms of where it's located, right? Its terminal line. Let's get rid of all this stuff because that's all wrong. Let's draw the actual picture that we're looking at here. Here's my XY coordinate grid, and here is my crazy spiral. Oops, wrong direction. We're going negative. Okay, around and around and around we go. And it's going to end somewhere like over here. Okay, right there, I think, because the coterminal to it was 95 degrees. And the crazy spiral angle was this negative 985 degrees thing. Now, if you're dealing with a radian, like, okay, let's use this one, negative pi. Well, I think we all know what negative pi is, right? That's just your coordinate plane like this, and you go around that way by negative pi. Well, that's the same as positive pi right here. They end at the same place. Now, what did I do there? Instead of adding 360, I did this. I did negative pi plus 2 pi. Okay? When you're finding coterminals in radians, you're adding 2 pi because 2 pi is one full circle. And when you're doing coterminals in degrees, you're adding 360 degrees because that is a full circle right there, right? We're unwinding that spiral, so to speak. So that's the idea with coterminals.